So we're going to now look at a part of the phosphorus cycle focused in the oceans and ask ourselves the question, how are humans changing the phosphorus in surface seawater? So for this exercise, what we're going to do is just break off a small part of the phosphorus cycle and try and model that in MATLAB. Hopefully it'll help you be prepared for working on your second problem set and solving that system of differential equations. So we're going to make a couple assumptions, and we're going to combine some biological and physical processes just for simplicity, then develop a two-box model with exchanges between those boxes, and add some specific fluxes into the surface ocean from rivers, but also have an output in the deep ocean driven by a process of sedimentation, or the settling of this phosphorus in the benthos, in the sediment at the bottom of the ocean, removing it from the water. We are given fluxes and flux coefficients for the transfer, but not steady state or current masses of phosphorus in these reservoirs. So these are things that we're going to have to figure out ourselves and do that before we really start to model how humans are changing it. So here's our two-box model of the ocean. You'll notice first that there's a river input going into the surface ocean that's exchanging phosphorus between the deep ocean through a sinking and upwelling process. Think of the ocean conveyor belt, moving the water and then the dissolved phosphorus in the water around. In the deep ocean, we have this other process removing phosphorus from this equation. And since we have a balance of inputs and outputs, we can hope that this system comes into steady state and hopefully model that it will come into steady state. Adding on some of the fluxes and flux coefficients that we were given, we see a couple things. We have this one flux describing the flux of phosphorus, the total mass of phosphorus coming out of our rivers into the oceans each year, and that's on the order of 21 times 10 to the 6 tons. That number actually comes from your book, which uses the units, I think, 21 times 10 to the 12, 21 petrograms, which is 21 times 10 to the 12 petrograms, or 21 times 10 to the 12 grams, I'm sorry. And then, because we have these dynamic processes going on, the flux of phosphorus throughout the rest of the system is defined by how much phosphorus is in each system. So these rate constants actually describe the removal of a proportion, the proportion of the total mass of phosphorus in each box that we have right here. So in this first one, you'll notice that in this first one, this K1 to 2 that describes the rate of phosphorus going from the surface ocean to the deep ocean, approximately 2% of the phosphorus in the surface ocean is transferred each year. And you notice a lot less is true for the upwelling. We want to start to define our equations, and if you just want to start down here in this middle set, we can basically write this out and make it a little bit easier for ourselves. If we imagine it to be define these equations basically in terms of fluxes, and then define each flux in terms of its rate constant and the mass of the source reservoir. So just starting right here, you'll notice right in the middle that dp1 dt and dp2 dt equals the flux of the river minus the flux going from box 1 to box 2, the flux of the surface ocean going to the deep ocean, and then then adding the flux of the deep ocean going then into the surface ocean. dp2 dt is a little different, and we notice that it's gaining the flux of water from the surface ocean into the deep ocean, but losing now this flux from the deep to the surface ocean, F21, but also now losing this flux into the sediment. Now these fluxes, except for the F river, can be defined in terms of our rate constants times the total mass of phosphorus in our system. Again, these rate constants describe the proportion of that total mass that is being moved out of that system. So what we're going to ask ourselves in MATLAB is, we'll add an additional flux of phosphorus that is basically parallel to what the river are doing, and basically watch the percent change in surface phosphorus between 1940 and 2100. All right, so just move on to the next